Hello, ladies and gentlemen. Welcome to the second sample problem from section 16.2. Second problem using the whole idea of calorimetry here. Um, in between the first and the second, the whiteboard that I was using that was online stopped working, so I'm going to try using a new one. See if it works out even better. We'll see. Well, let's go ahead and try this problem right here. This problem right here says a hot piece of iron at 85 degrees Celsius is placed in 300 grams of water originally at 23 degrees Celsius. If the water and the piece of iron come to thermal equilibrium at 34.6 degrees Celsius, in other words, that's where they kind of met, the iron cooled off and the water warmed up, and the temperature of the iron came down, temperature of the water went up, and they finally met at 34.6 degrees Celsius. And that's where they stopped changing. What was the mass of the piece of iron? Okay, so let's go ahead and do this problem right here. And let me get a pen right here to use. There we go, we got a pen. All right, so what's happening here? Once again, I've got my calorimeter here. And in the calorimeter, we have water. There's 300 grams of water. And we have this piece of iron. So there's your piece of iron. Okay. And so since the piece of iron is hotter than the water around it, then energy is going to flow out. And so therefore, iron is going to lose energy as heat. And it's going to go into the water. So as we've seen before, you use your equation Q of iron is going to equal to minus Q of water. Okay? And remember that Q always equals to mass times specific heat or specific heat capacity times delta T of a substance. So we can use this equation, and we can substitute mc delta T both for the iron and for the Q of the water. Right? What we're looking for is we're looking for the mass of the piece of iron. So I can write this for Q of iron. I can substitute it in with mass of iron times specific heat capacity of iron times the change in temperature, delta T, of iron is equal to the minus Q. And so the Q of water is mass of water times the specific heat capacity of water times the temperature change of water. Okay, so we substituted mc delta T for the Q of iron and mc delta T for the Q of water. Okay, notice we put negative here because one of these delta T is going to be negative, the other one's going to be positive, and we want to make sure that they cancel each other out. What we are looking for is the mass of the piece of iron, that's this one, which means we should have, let me go ahead and change the color here. We should have, in order to cancel this out, we have six variables in this equation. C of iron, we have that. Delta T of iron, we can calculate that out. The mass of the water, we're given as 300 grams, specific heat capacity of water, and the delta T of the water. All these things you either have or we can calculate out. Okay, now let me go back to this. So let's plug in. Mass of iron is what we're looking for. Specific heat capacity of iron we're given up above here, 0.446 joules per gram degree Celsius. So it's going to be 0.446 joules per gram degrees Celsius times the delta T of the iron. The delta T of the iron went from, let's do the calculation up here. Not exactly sure how this board works, so I'm going to try not to have to scroll. The other one scrolled. The iron went from 85 degrees Celsius to 34.6 degrees Celsius. So I'm going to take the 34.6 degrees Celsius and subtract the 85.0, right? It's always final minus initial. Where you ended up minus where you started. And that's going to equal to, let's see, If I get my calculator, so I can make sure that I'm doing this right, 34.6 minus 85.0, it's going to give me minus 50.4. So it lost 50.4 degrees Celsius. Degrees Celsius there. There we go. So that's what we're going to go ahead and do. We're going to go ahead and put that in there, minus 50.4 degrees Celsius. So that's your M times C times delta T for the iron. Now we don't know what the M is, and that's what we're looking for. That's going to equal to the negative of the M for water, and we're told we have 300 grams of water, so 300 grams is your mass for water. Specific heat capacity is given up here, 4.184 joules per gram degree Celsius. We've seen that in problems before, 4.184 joules per gram degrees Celsius. And all we need is the delta T, and we know that it went from 23 to 34.6. So that one, delta T for the water, again, it ended up at 34.6. My 4s keep looking like 9s. Degrees Celsius. Then you subtract the temperature you start off at, 23.0 degrees Celsius. That one, 34.6 minus 23 is 11.6 degrees Celsius. So it went up positive 11.6 degrees Celsius, so we can put it in as just a regular 11.6 degrees Celsius. And now we have an equation with just one unknown, right? And so let's go ahead and solve for what the mass of the iron is. So in order to get mass of Fe by itself, what we're going to do is just going to divide through by the ones we want to get rid of on the left side, 0.44 joules per gram degrees Celsius. So these guys cancel. And because we divided on the left, we must divide on the right, 0.446 joules per gram degrees Celsius. And then we also have to get rid of the negative 50.4 degrees Celsius so that these guys cancel. And because we divided on the left, we must divide by that number on the right, negative 50.4 degrees Celsius. Okay. See how important this negative is right here now? This negative is going to cancel out with this negative. So now you're going to end up with a positive number, because if you had a negative number, if you didn't have this negative here, this negative would have stayed and we would end up with a negative mass. What does it mean to have a negative mass? So your mass of your iron is going to equal to 300 times 4.184 times 11.6 divided by 0.446 and divided also by negative 50.4. We also have to take that negative also, and the negatives cancel. And we end up with, let's try that again, 300 times 4.184, just plugging these in the calculator, times 11.6 divided by 0.446 and divided again by 50.4 is going to give us 648. So now we have, let me get this right, 648 grams of iron. And there's your answer. Okay, so now we got an answer for it. And you'll notice, once again, let's go over what we did. I'll do this in green as the review. So we had iron. Iron had a certain amount, iron was hot, had a certain amount of energy in it. And as it came into the water was cooler, so the heat came out. We're trying to take into account the fact that iron lost energy and water gained it. So Q for the iron is equal to minus Q of the water. Whatever energy was lost by Q, in other words, iron had a negative Q, and the negative of negative is positive, so water had a positive Q. we substituted MC delta T for water and for iron, for the Q's of water and for the Q's of iron. And when we did that, we found that, well, we were looking for this. We were given this, this, and the problem, this, or this. The delta T's were things we could calculate because we're just looking at differences in temperature. So here's this delta T for the iron, here's the delta T for the water, everything else we're given. Once we calculated these and we plugged in the specific heat capacities and the mass of the water, we can solve for the mass of iron. And everything else canceled on this side, and even our units here, well, here joules per gram degree Celsius, the whole thing cancels with joules per gram degree Celsius here, the degree Celsius here cancels with the degree Celsius there, and what we were left with was just grams, which is the units that you need in order to solve for mass. Okay, so hopefully that was helpful. If you're interested right now, you can go ahead and stop the video. I'm just going to try some things on here and see. Oh, look, it does move. The whole thing moves. And if I choose that, I wonder if I can get that to move. Yeah, okay. So I do like this board too. There's several boards online that we can use. Okay, so hopefully this was helpful to you and helpful in your problems that we did.